Hello and welcome to another session of the Digital WE Days. My name is Silas Ton and I will moderate this webinar today. The topic of today is configurable industrial control solutions featuring power efficiency and diagnostics, enables future locking platform designs. Our speaker today is Michael Collings from Analog Devices. Michael, welcome and cool to have you here today. Reducing power and maximizing uptime are key in factory automation. But how does adaptive switching help cut heat and BOM? Let's find out, and stage is yours, Michael.
Welcome to today's webinar, where we're going to take a look at some of Analog Devices' latest industrial control solutions. My name is Michael Collins, Product Marketing Manager. I hope you enjoyed this webinar. I hope you learned something from it, and I look forward to your questions at the end. Before we look at some of the solutions, I think it's first important to take a focus at the issues or the pain points that we are trying to address. So in today's industrial environments, modern factory and process control systems, they face critical challenges. And these include, the demand for factories to minimize any downtime to ensure that they have good operational efficiency, lowering power, and that's not just referring to the cost of operation, but also having implications for heat dissipation, especially within multi-channel space-constrained modules. Minimizing the bill of materials has advantages when it comes to reducing the inventory or the stocking levels that are required. And where possible, if a similar design can be reused or a similar approach can be taken for multiple end applications, it certainly brings about efficiencies in terms of reuse and reducing our customers' overall time to market. So today, we're going to take a look at two recent product releases from Analog Devices, which I believe address many of the challenges or the macro trends of the industry. And to me, these are more than just products. They're complete configurable solutions that target and address the customer pain points. So the first one we're going to speak about is the 5460. It's a quad channel device which offers both voltage and current configurability at the same pin. And it also supports integrated diagnostics and power efficiency. And there are some overlapping features that you will see on the 5460. And the second product that we're going to speak about today, which is the 874416H. And this product, it brings configurability to a whole new level. Configurations at the same pins. And whether you decide to drive an actuator via a voltage or a current, or you decide to drive a relay, or you may decide that you want it to be reconfigured to read back from a sensor or a thermocouple or a 2 or a 3 wire RTD. This is a premium reconfigurable product that complements Analog's existing software I/O portfolio. Let's dive in and take a closer look at the 5460. Now, this is a quad channel 16-bit output solution. It offers high channel density voltage or current output at the same pin, and customers may choose this as a building block in developing an 8-channel or a 16-channel or a 32-channel overall in system, and it has that ability to reduce the overall size. By default, high Z is set to the output for safety. It has onboard or on-chip diagnostics, which support open circuit and short circuit output detection. It has inbuilt protection for these features as well, but it also can monitor the different supply voltages, has a reset status, has an internal temperature diode measurement, and a watchdog timer for detecting if there's any issues with communicating with the micro. It also supports a feature which I'll go into a little bit of more detail later, which is called adaptive power switching. And this allows, I guess, optimum power supply. It allows for the optimum power supply to be chosen by the part, whether this is AVDD high or AVDD low. And like I say, we will go into this in a little bit more detail. The BART itself offers high precision with feedback sense pens, allowing for precise control of the analog output. And it has a wide supply range, but also a wide supply tolerance of up to plus or minus 50 volts on the output with respect ground. So this complete system diagram shows some of the companion components that can be used in conjunction with 5460. So let's analyze this diagram in a little bit more detail from the top left of the picture, where you can see the typical backplane voltage supply of maybe 24 volts. And the voltage rails that are required by the part can then be generated from this 24 volt supply by choosing one of our flyback controllers, which offers both isolation and power efficiency. As you can see, each of the output channels can be further protected from transients using an external TVS. The interface, the digital interface to the micro, can be isolated by one of our digital isolator products. As you can see, it is a complete solution requiring minimal external components. Now, digging in a little bit further and looking at the diagnostics, pinpointing, or the ability to pinpoint exactly where a system issue may exist, offers huge advantages to the user to take action and fix that issue. And this part offers multiple diagnostics from supply, individual supply detection, opens and shorts at the output. It has temperature alerts, SPI, CRC, error checking, among many others. Now, it is true that these diagnostics, they can be implemented in alternative ways off chip, but there is an added value in an integrated approach. Internal signals or voltages can also be switched out through the ANA MUX out pin, which can be measured by an external ADC, which is another useful way in implementing an independent means of diagnostics. Adaptive power switching is a design technique used to minimize unnecessary power dissipation on the chip. And this is really important in space-constrained modules or cards. And why? Well, simply, if you have less space for the same power dissipation, it will result in greater heat generation. And without any means of dissipating this heat, the modules, the cards, they're often simply derated to reduce the maximum power. And this restriction is usually hidden deep within the terms and conditions of product usage. So the advantages of having a smaller size cannot be fully realized without some form of an intelligent power management feature. Using a feedback loop, both products that we're discussing today, the 5460 and the 874416H, both products independently determine the optimum supply based on meeting the minimum headroom requirements on the analog output pin. And then the solution automatically switches to use the lowest supply rail, reducing the overall power consumption or reducing unnecessary power dissipation from a higher supply rail, which is unnecessary under certain conditions. And the bar itself has inbuilt Hysteresis, again, ensuring that no unwanted switching takes place within the region of supply transition. And the plot here shows the effect of increasing current into a fixed resistive load and driving 25 milliamps into an increasing resistive load. Again, both showing the same effect, part switching internally to the lowest supply rail while maintaining the correct output value. And here we can see some thermal images of the part under these different configurations. And these images were gathered in an ambient lab environment with the 40% reduction in power, resulting in a significant reduction in heat. As you can see here, it's close to a 16-degree difference in overall temperature. Now, you could argue that 80 degrees C is still within the operating temperature of the part, which is true. But if at T0, the module itself is already enclosed within a much warmer environment, the initial temperature may be higher. So it's that delta figure which is all important. Now let's take a look at the next part. The 874416H is a quad channel, fully configurable product with integrated heart per channel. And it essentially offers the user the ability to program any function on any output pin, whether that's an input or an output, analog or digital, driving out current or voltage, a 2 or a 3-wire RTD, or supporting thermocouple measurements. And the part itself is configurable, but it's also reconfigurable in real time over a simple SPI interface. So it offers a single platform for reusable designs. This product, I believe, is a premium product that complements our overall software I/O portfolio. And it has some performance improvements over the existing quad channel. And the existing quad channel is the 874413R. So the 16H is a premium product above and beyond the 13R, as it supports digital output functionality, driving out a digital output through the use of an external FET. It also supports leakage compensation. So should the end customer select a suboptimum FET, the part itself can do a calibration of that leakage current. It supports integrated heart modem per channel, and it also supports the active heat or power management features that are common to the 805460, which is that adaptive power control or adaptive power switch. Again, a similar block diagram to the 805460 is shown here, again with the power architecture, very similar to that product. Again, minimal external components are required. As I mentioned, the DO FET is external, and this also ensures that there's less heat dissipation on the part. It does require an external precision ORF sense resistor per channel for optimum overall accuracy. In addition to many diagnostics featured on the 805460, this part also offers an auxiliary ADC input, which allows the part to be used in a redundant type application. And if we follow the latest direction around functional safety or safety standards, there's certainly a balance between having all the diagnostics on the one chip and having an auxiliary ADC for some independent self-checking. So this product does allow that. Like I say, a similar power architecture to what was implemented on the 5460 is used on this part, again with the voltage headroom determining which supply rail is providing power to the load. And again, no user input is required in this. The part itself monitors the load conditions and selects the lowest supply according to those. The plot that we can see on the right clearly shows the part transitioning between those supplies with the resultant power savings using the adaptive power switching feature. For bench measurements and thermal imaging that we have used to highlight this feature, the setup is shown here with each channel programmed to drive out 25 milliamps and show the effect of the power supply transition. The outputs are then put into a short circuit condition. We can see in the next slide, these are the two thermal images, which clearly show the difference in power due to enabling or disabling the adaptive power feature on the 8054 or 87441-6H. And again, in this case, we see a delta of 18 degrees C, which is significant if you are at the higher end of a temperature of a module. Again, we have another neat image shown here, remembering that the part itself supports 4 different channels, and this highlights the thermal gradient across the part by incrementally disabling the adaptive power switching. So looking at this slide from the top left, and then working around maybe in an anti-clockwise direction, we can see, first of all, top left channel A being disabled. Then next, bottom left, we have channels A and B being disabled, and so on around to the top right where adaptive power switching on all 4 channels are disabled. Overall power consumption data was gathered using real measurements, real data of the supply voltages and currents, and then we calculated the resultant power. It's also worth noting that the eval board that was used to gather these measurements has good thermal performance, as it includes a small PCB as part of the layout. It supports a heat sink plane on the bottom layer connected to the chip, which has an exposed pad to the ADSS signal. So obviously the real world measurements will change depending on how much attention the end customer offers to thermal dissipation. But there are other factors as well that will affect the difference in power dissipation, and these include the space constraints of the card and possibly any airflow that has been designed in to move heat away. Again, power rails were optimized considering the worst case data sheet power consumption specs. Now, the reduction in overall power, it is significant, and it is up to 40% under these real user mode conditions. So let's recap on the industrial control, the macro trends that we looked at to address at the start of this presentation. So the role of integrated diagnostics enhances the ability of the part to be used in a safety end application. The software reconfigurability of both of these parts helps with simplifying the overall design process, and it also offers a platform for use. So whether the customer decides to label a product as a SKU for driving out voltage only, or they decide to offer full configurability to their end customer, the part can be configured in the factory when it's commissioned, or it can be reconfigured by the user in real time. In addressing the need for lower power analog devices, latest products effectively tackle this heat dissipation issue through adaptive power switching. This leads to a power reduction of up to 40%. Integrating more functionality and performance onto the one part again offers the ability to reduce the overall bill of materials, and not just at a component level, but having a single part that can perform functions can reduce the need to stock multiple SKUs. And this further helps with a future-looking design platform, reducing the customer's time to market and design cycle. So that concludes my webinar. I'm happy to take any questions.